Good morning, students. Today I am continuing with the chapter number 6, and the name of the chapter is Application of Derivative. In this chapter, today I am continuing with the one of the important concept, that is maxima and minima. So, what is maximum and what is minimum? So, first we will go through with one graph. With the help of this graph, it will more clear when function is maximum and when it is minimum. This is the graph related with x and y axis. So if I am saying y equals to fx is a function where x is related with the closed interval a comma b, then how can we will plot it? This is the a point, this is the b point, and these are the x and y axis intersect at point O. Then we can say P point, Q point, R point, and S point. These are the tangent at these points, and we will join these points with x axis. This is x equals to a, and this one is x equals to b. We will join these points with the x axis in such a way. Okay, so as you see here, these points P, Q, R, S, tangents are there, and these tangents are parallel to x axis. Okay, so we can say at point P and R, the function fx, or we can say at these points, value of the function is maximum. Okay, and points Q and S, here the value of the function is minimum. So these 2 points are the maximum points, P and R, and Q and S, these are the minimum points, and these 4 points are also known as extreme points. Right, so this is the concept of maximum and minimum for a function fx in the closed interval a comma b. After this graph, we will continue with some definition which are related with maxima and minima also. So first I am continuing with definition critical points. What is critical points? Critical points. So in critical points, we can say a point x equals to c. A point x equals to c is called critical point of a function fx if fc exists, and either we can say f dash c equals to 0 or f dash c equals to infinity. Then x equals to c is known as critical point. After critical point, we will continue with definition point of inflection. So what is point of inflection? If fx is a function and x equals to c is a critical point, okay, of that function, then we can say x equals to c is known as point of inflection if f dash c equals to 0, f double dash c equals to 0, and f triple dash c not equals to 0. Then we can say x equals to c is known as point of inflection. So after this definition of point of inflection, we will continue with the definition monotonic function. What is monotonic function? So a function is said to be monotonic function in an interval if it is either increasing or decreasing. If it is either increasing or decreasing in that interval. Okay, then that type of function is known as monotonic function. Then we will come to on the next point, that is stationary point. So what is stationary point? For a function fx, if f dash x equals to 0, or we can say f dash c equals to 0, so that type of concept is related with stationary point. So after these definition, the all definitions are related with maxima and minima. So after this definition, I am continuing with the absolute maximum and absolute minimum concept. So if fx is a function defined in an interval I, then we can say f is said to be absolute maximum at a belongs to I if fx is less than equals to fa for every x belongs to I. This is related with absolute maximum, and this function fx is related with absolute minimum, right, at b belongs to I if fx is greater than equals to fb for every s belongs to I. So this is the concept related with absolute maximum and absolute minimum. So after absolute maximum and absolute minimum, we will continue with the concept local maximum and local minimum. Now we will continue with the local maximum and local minimum concept. So we can say a function fx is said to have a local maximum at x equals to a if there exists a neighborhood I means interval of a, such that fa is greater than equals to fx for every x belongs to I. Then we can say fa is the local maximum of that function and a is known as point of maximum. On the same time, we can say fx is said to have a local minimum at x equals to a if there exists an interval I of a such that fa is less than equals to fx for all x belongs to I. Then we can say this fa is related with local minimum, and here a is the point of minima for that function. So this is the condition related with local maximum and local minimum. Now I am continuing with some graph, and with the help of this graph we will easily identify, or we can say, when function is related with local maxima and when function is related with local minima. So for example, this is the graph from you can say negative to positive for a function, and these are the sign of f dash x, right? One more graph we are taking on the same time for the function fx. This is positive to negative, and these are from negative to positive, right? Positive to negative and negative to positive, and again these are the sign of f dash x, sign of f dash x. Now again I am taking some graph. This is negative to negative, sign of f dash x, and here I am taking positive to positive for a function, So as you see here in this graph, sign of f dash x is positive to negative. So this type of situation, when the symbol of f dash x is positive to negative, we can say for such type of situation, function is local maximum, right, at a point x equals to c. And when the situation related with the sign of f dash x is negative to positive, that type of graph is related with local minima, right? And whenever the sign of f dash x is minus to minus for a point x equals to c, so in that case we can say the given function is neither a local maximum nor a local minimum. Same in the case of positive to positive. So with the help of these symbol, we will easily identify when the function is local maximum, when the function is local minimum, and when it is neither a local maximum nor a local minimum. So everything depends on the situation. What is the situation of f dash x? On behalf of this situation, on the behalf of the symbol of f dash x, we will easily identify when it is local maximum, when it is local minimum. Now I am continuing with the steps of finding maximum value or minimum value. So this is very important concept. If when function is given, how can we will identify when it is maximum or minimum and what is maximum and minimum value. So in step number first we will write the function, that is y equals to fx. In second step we will write or we will calculate the differential from that function, that is f dash x. Okay. In third step we can say at a stationary point f dash x becomes 0. It means we can say dy by dx equals to 0. In fourth step we will calculate the value of x. What is the value of x? It may be one value or more than one value. In fifth step we will go with the double differentiation. Okay. In sixth step we will check this double differentiation at the value of x. So here we have to pay attention. After putting the value of x in the double differentiation, if we are getting positive sign, then we can say function is maxima here, and if we are getting it is minima, and if we are getting negative sign, then we can say function is maxima here. So this is the turning point of this question or these steps. When you will put x value here in double differentiation, and if we are getting positive sign, then we can say function is minima here. If we are getting negative sign, then function is maxima here. Then we will mention at the particular value of x, the given function is maxima or minima. After identifying maxima or minima, we will continue with the seventh step. What we will do for finding the value of maximum and minimum value, for finding maximum or minimum value, you can say we will put the value of x. We will put the value of x in fx, right? So it means first we will calculate maximum or minima for a particular value of x, and after calculating the value of x, we will put that value of x in the given function, and then we will say yes, it is maximum value or minimum value. So these are the steps related with finding the value of maximum value or minimum value of a given functions. So with the help of these steps, we will continue with some question related with our exercise 6.5. So at present I am taking one question from the exercise 6.5, question number first, and there are 4 subpart. I am taking third subpart of this question, and the question is find the maximum and minimum value of the following function, and the function is fx equals to whole square of x minus 1 plus 10. So how can we will calculate maximum value and minimum value here? So first we will do the differentiation. When we will do the differentiation, we will get 2 into x minus 1. At stationary point, we will put f dash x equals to 0. So what we will get, 2 into x minus 1 equals to 0. So x minus 1 equals to 0. That's why we can say the value of x is 1. Right. After this, what we will do, we will continue with the second differentiation, and when we will do the second differentiation from here, what we will get only 2. This second differentiation, we will check at the value of x, that is 1, but there is no variable, so it remains same, so that we will get 2, that is positive. That's why we can say it is related with minima. Right. So after this, what we will write? So the function is minima at x equals to 1. But we have to calculate minimum value. So therefore we can say, therefore minimum value, what we will do, we will put x equals to 1 in the given function, and when we will put in the given function, it can be written as 0 plus 10, so we will get 10. So this is the way of solving the question of finding the minimum value and maximum value. Here function is minima, that's why we will calculate only minimum value here. In some question, if minima and maxima both are there, then we will easily identify both the value at a time. So this is the way of solving the question. Now I am taking fourth part of this question, and we will follow the same procedure. And this time fourth part is, we have to give one gx equals to x cube plus 1. Right. This time this is given to us. So again same procedure. First we will do the differentiation. What we will get? We will get 3x square. So for stationary point, as per the definition of stationary point, we can say g dash x equals to 0. Right. After that, we will put the value of g dash x, that is 3x square equals to 0. So we will get x equals to 0. So in the next step, we will continue the double differentiation. Double differentiation we will get from here. This is our 6x. At double differentiation, we will check the value of at x equals to 0. So we will get 0 here. So we can't identify if it is positive, is negative or negative, because we know variable 0 is neither positive neither negative. So in this case, what we can say here x equals to 0 is a point of inflection. It means given function is neither maximum and nor minimum. Okay, because here we can't identify it is positive or negative. Maximum or minimum concept is not there. That's why we cannot calculate maximum value, minimum value. So we will mention here x equals to 0 is a point of inflection. It means given function is neither maximum and minimum. So after this question, we will continue with one more question that is related with absolute maximum and absolute minimum. How can we will solve such type of the question? Procedure is same. There is little change in calculating the value of absolute maximum and absolute minimum. So I am taking this time one question, that is the question number 5th, and I am taking the 4th part. Question number 5th, and I am taking the 4th part related with absolute maximum or absolute minimum. So find the absolute value and the absolute minimum value of the following function in the given interval, and this time we have to given fx equals to whole square of x minus 1 plus 3 with interval x belongs to minus 3 comma 1. So if such type of situation is given to us, how can we will calculate? So again same procedure. First we will do the differentiation. So we will get 2x minus 1. After that we will put at stationary point f dash x becomes 0. So we can say 2x minus 1 equals to 0, so that x equals to 1. Right. Then we will continue with the, so x equals to 1 lie in this interval. So what we will do, how can we will calculate absolute maximum or absolute minimum here? So after this we will calculate f minus 3, f 1. Okay. So when we will calculate it, f minus 3 we will calculate from here. So minus 3 minus 1 whole square plus 3. So what we will get, minus 3 and minus 1, minus 4 whole square is 16 plus 3 is 19. And then we will calculate this 1 minus 1 whole square plus 3. What we will get? We will get 3. Okay. So after this we can say the absolute maximum value is 19 at x equals to minus 3, and the absolute minimum value is 3 at 1. So we mention here. So absolute maximum value is 19 at x equals to minus 3, and absolute minimum value is 3 at x equals to 1. So this is the way of solving the question related with absolute maximum value and absolute minimum value. Here we are getting x equals to 1, which is lie or which is related with this interval, so that we will easily calculate it. Now I am continuing with one last question that is related with local maximum and local minima. So this time I am taking question number 3rd. So in question number 3rd there are various subparts are given. So I am continuing with question number 3rd. And in question number 3rd, I am taking one part, that is the 3rd part of this question. And the 3rd part is hx equals to sin x plus cos x. And here the value of x lie between 0 to pi by 2 in open interval. Okay, and what is given in this question? In this question we have to find the local maximum and local minimum values if any of the following functions. Find also the local maximum and local minimum value as the case may be. So again we will go through with function first. So we will get this. Again same pattern. At stationary point we can say f dash x equals to 0, so that we will get cos x equals to sin x, and it becomes tan x equals to 1, which is equals to tan pi by 4, or x equals to pi by 4. X equals to pi by 4 is lie in this interval. After this, what we will do, again we will go with the double differentiation. It is basically h, so we will write here h, and we will do the double differentiation from here. So what we will get minus sin x minus cos x. So we will put the value of x here, that is pi by 4. So minus sin pi by 4 or minus cos pi by 4, it is minus 1 upon under root 2 minus 1 upon under root 2. So we will get minus 2 upon under root 2, that is minus under root 2. That is the negative. So negative value is there, that's why we can say it is local maxima. So for the given function, we can say it is local maxima. And how can we will calculate local maximum value? For finding the value of local maximum value, what we will do, we will put x equals to pi by 4 in the given function. So what we will get, sin pi by 4 plus cos pi by 4, right? And when we will solve it, we will get 1 upon under root 2 plus 1 upon under root 2, that is 2 upon under root 2, and we will get under root 2. So this is the way of finding the local maxima and local maximum value. Because maxima is there, that's why we will calculate local maximum value. If minima is there, then we will calculate local minimum value. So I hope with the help of these questions, in which I told about maximum value, minimum value, absolute maximum value, absolute minimum value, local maxima and local minimum value, we will solve the other question which is related with that. And we have to follow the procedure which is related for finding the value of maxima and minima related with the steps. So it is a very interesting concept. So please do the remaining question related with these points, go through with the definition. Thank you very much.